Briefly, before we get to design patterns, it's helpful to think about the design of our classes in our application. So we're going to talk about just enough UML. UML is a universal modeling language. It's not a text language, but it's a notation for describing object-oriented systems, essentially, is how do we draw out the relationships between classes, between components. And there's a lot of UML, and we'll see in a second about all the different types of UML that exist. But the goal here is that drawing out these small cards can help us describe the relationship. So we might say in this example that car is a subclass of vehicle, that an engine is a component of a car. The arrows, the circles, will denote certain properties. We'll talk about that. And this case shows us that the engine class includes a couple methods like start and stop. The diagrams will adapt over time. But one of the things that I do think is helpful about this is just the practice of finding a tool to visualize what is going on in your application. There are tools in Ruby and other languages that automatically generate UML diagrams from your active record relationships. So we'll look at the output of a couple of those. But our goal here is to give us a tool that helps us see at a higher level what's going on in our application. So this is a screenshot or a subset of Armando's audience first application, these models that are actually in the application. And there's a lot of stuff going on here, but it's also, I would say, the things that we should take away are, in some sense, relatively simple or the higher level concepts. So in this version, we're not listing out every single attribute that an individual class knows about. If you were to go look at this app, you could go look at like the item or the voucher type tables and see that they do have quite a bit more columns. But what we're really trying to understand is the relationship between various classes. So in a UML diagram, if we have this open circle right here, so this might be a little bit small, this open circle, and typically we'll see that there are two of them on a particular class. This denotes an aggregation. So an account code, if we think back to chapter 5 in this case, is a join table of an item and a voucher type, which is where the two arrows come from. But essentially, this is telling us that this thing aggregates two different types. If we have a diamond, this diamond tells us that we are composing two classes together such that an item has a relationship to a customer, but it's not a dependency, right? There's no customer doesn't inherit from item, but a customer and an item are linked through, in this case, a foreign key. And the final thing to take away from this is that arrows do note inheritance. So in this model, we have two different types of objects, a voucher and a donation. In this model, both of these things are a subclass of the type of item that might have specific properties. And you can imagine, right, that in this case, they would operate a little bit differently, but they should be able to do the same types of actions. So both vouchers and donations would then have some relationship to a particular customer because the item itself has that relationship. We're not going to get too much into the specifics, but the UML diagrams as well also allow us to denote with either a 1 or a 0 or a ... whether or not there is 0 or more of a class that's linked. So whether this is sort of a has many relationship, or if it's just one, then that could be a has one or a belongs to relationship, depending on the direction that you're going. So our UML diagrams will help us sort of structure the relationships and visualize them in our classes. And if you have a Rails app and you run through the code that generates the UML diagram, it will look at your calls like has one and belongs to generate the exact labels that exist in the relationship. So this is what a full UML diagram is. Our goal in this class is not to have you draw them all out, but be able to look at one and pick out the higher level concepts of what's going on. Again, we typically think of these things up here as attributes that belong to a class. And these are the methods or the actions that that class can do. Remember that in Ruby, everything is a method call. So calling price on an item perhaps is still a method, but we typically treat that as an attribute rather than an action. So in our classical drawing, we'd still separate those out. You can have too much UML, and in fact, you can use a UML chart to model the ways and various types of UML. This is where we can say sometimes things jump the shark a little bit. Our goal is really to just focus on class diagrams in this class. That's the specific type that we're going to be looking at. But there are many different ways of applying UML. Some of them you'll encounter, such as specific tools for architecting systems design and drawing that out. But really what I would say is you shouldn't be focusing on trying to memorize every single detail of what can go into a UML chart, but being able to take away the higher relationships. So inheritance, aggregations, compositions, those things do affect how you work in an app day to day. But if you're curious, there are many different types of UML charts. One of the tools that helps us build UML charts, whether by hand or thinking about architecting the code, are what we can call class responsibility collaborator cards, or CRC cards. You can do this ideally in the design stage of an application, but also if you have an existing application, you can go backwards and draw these out. They help us think about any given class, what are its relationships to other classes in our application. And we're not typically trying to think about, right, at this level, does a particular model inherit from active record? But at a higher level, what are the things that we care about? So if we have, again, in audience first, this would be in rotten potatoes. If we have something like a movie showing class, assuming that we build a feature that lets us sort of track ticket sales, a movie showing would need to relate and have a reference to the particular movie in our database that it relates to. If we have an order for movie tickets, we would need to have some kind of responsibility that says this order object knows something about a particular ticket. And of course, that means that we have a ticket model, which might have a reference to a particular showing, which is what is this particular ticket, what show is it tied to. And then, each of these has functions that the class needs to do. Like a ticket would have a price, perhaps. It needs to know whether it's valid. Those functions might not need to interact with other classes, so they wouldn't have that responsibility, wouldn't necessarily have any collaborators. But what we're really thinking about is, at a high level, what are the goals that this thing does? And then in order to accomplish that goal, what class does it need to interact with, or what other objects? These help us plan out the relationships between different models, perhaps in our database. You can also sort of nicely think about how these translate to user stories. So if we had a feature which says adding movies to a shopping cart, so as a patron, so that I can attend a showing of a movie, I want to add tickets to my order, you should be able to take a scenario and pick out the nouns, which are typically going to be the models in your application or the objects that you care about. So in this case, a patron, whether that model is actually called patron or user. We have a showing, a movie, tickets, an order. In this story, we're dealing with a few different models that exist. And then we have a couple particular actions so that I can attend a showing. Whether or not attend is the method in your app, that could be what you call it. This could be your scenario's translation of something more complicated, but that is one action, right? We could redeem a ticket, or we will need to redeem a ticket in the future. And I want to add tickets to my order. So we know that a ticket needs to interact with an order, and that adding a ticket to some order is some action that we'll need to take care of. But the idea here is that we should be able to draw these out on sort of a simple interface, and that can help us guide how we might write certain kinds of user stories. But the goal of all of these things is to focus on a higher level version rather than the individual calls, perhaps, that exist in a model.